Hello everyone, welcome back to another video. This is the second part of air pollution. In the previous video, we have covered criteria air pollutants in detail. In case if you haven't seen that video, you can check it from the link given in the description. In today's video, we are going to learn about smog, and at last we will also see some questions related to this. So make sure to watch it till end. First of all, we should know that what is smog. So smog is a type of air pollutant which exists as aerosols, and it is formed when smoke and fog combines together to form an intense kind of air pollution that reduces visibility. Smog word was first introduced by Dr. Henry Antony in his paper Fog and Smoke, and it is measured by Ringelmann scale, which measures the great density of smoke. There are two types of smog. First is London smog and second one is Los Angeles smog. Now let's know about them in detail. First type of smog is London smog, which was first observed in the city of London in the year 1952. The other names of London smog are industrial smog, classical smog, reducing smog, and sulfurous smog. The pollutants involved in the formation of classical or London smog are smoke, fog, and sulfur dioxide, which is mainly released by the combustion of coal. Next, let's see the formation of London smog. London smog or classical smog forms when smoke, fog, and sulfur dioxide combines together at low temperature to form the vapor of sulfuric acids. So basically, in the formation of sulfurous smog, sulfur dioxide is oxidized to form sulfur trioxide, which is a secondary pollutant. And now this sulfur trioxide combines with water droplets which are present in the fog to form sulfuric acid. This sulfuric acids get deposited on the other particles which are present in the atmosphere and causes the intense condition of smog. One important point to note is that the sulfurous smog only forms at low temperature. That's why it is also known as winter smog, and the intensity of formation of sulfurous smog increases with sunlight, because as sunlight increases, the intensity of formation of SO3 also increases. So more sulfuric acid is formed. This sulfurous smog causes the color of atmosphere grey. That's why it's also known as grey smog. Second one is the Los Angeles smog, which was first observed in 1943. The other names of Los Angeles smog are photochemical smog and oxidizing smog. The main pollutants involved in the formation of photochemical smog are ozone, hydrocarbons, and nitrogen dioxide. This photochemical smog is formed when oxides of nitrogen combines with other volatile organic compounds in the atmosphere in the presence of sunlight. For the formation of photochemical smog, as the name suggests, sunlight is required. So it is light induced smog and is mainly formed in the summer season. Photochemical smog has many adverse effects. One of them is the cause of eye irritation, but this is mainly caused due to the formation of PAN products, that is peroxyacetyl nitrate, which is brown in color. That's why photochemical smog is also known as brown smog. Now let's see the reactions, that how this PAN is formed. As we have learned in the previous video that nitrogen dioxide helps in the formation of ozone, whereas nitric oxide helps in the destruction of ozone. So, in the presence of sunlight, photolysis of NO2 or nitrogen dioxide takes place, which gives us NO, that is nitric oxide, and one nascent oxygen. When this atomic oxygen combines with molecular oxygen, ozone is formed. Now, this ozone, when combines with nitric oxide, the formation of nitrogen dioxide takes place again. But if hydrocarbons are present in the atmosphere, then these hydrocarbons will combine with the atomic oxygen to form highly reactive intermediate, which is also known as free radical, and this free radical helps in the formation of many highly reactive pollutants like formaldehyde, peroxybenzoyl nitrate, and peracetyl nitrate, that is PAN. The presence of excess ozone along with aldehydes, ketone, and PAN constitutes the photochemical smog. Let's know the effects of smog. First is, inhaling smog over a long span of time can inflame our breathing passage, much like cigarette smoking. Second, it also causes inflamed lungs and may cause blood clots in people and respiratory disorders, which lead to heart attack and strokes. Third, smoke can dry out the protective membrane of our nose and throat. Fourth, it can reduce the body's ability to resist infection, hence increasing our susceptibility to illness. Fifth, it can greatly decrease the ultraviolet radiations, leading to low production of important elements like vitamin D. Now, let's see the remarkable solutions to smog pollution. As the study shows that the transport sector is the highest contributor to oxides of nitrogen and volatile organic compounds. Hence, there is a need to take strong actions on these high emitters, including vehicles and other industries. We must reduce the secondary air particles, which involves in the formation of ozone. Third, as ozone is now a round the year problem, so the situation demands the refinement of air quality action plan to mitigate ozone. Fourth, it is important to calibrate air quality index to report the most polluted cities. Now let's know that what is air quality index. Air quality index measures how safe the air around you is for breathing, and the widely used National Air Quality Index is given by Central Pollution Control Board and is a 24-hour average. Its unit is microgram per cubic meter. A particular amount of one pollutant may not be as harmful as the same amount of another pollutant, so each pollutant's quantity in the air is adjusted to a common scale that works for all pollutants. And finally, the pollutants with the worst sub-index determines the air quality of the time and location. In air quality index, the descriptive term ranges from good to severe, and here the air quality index value of 50 indicates good condition, whereas from 400 to 500 indicates severe condition. There are 8 pollutants which are measured to tell the air quality index, that are sulfur dioxide, nitrogen dioxide, particulate matter 10, particulate matter 2.5, ozone, lead, carbon monoxide and ammonia. These pollutants are also involved in National Ambient Air Quality Standards, which we will be describing in the upcoming video. Now, let's see some questions to recall what we have learned today. After reading the question, I will wait for some seconds so that you can also guess the answer. First question is, which of the following is a major photochemical oxidant? As we know that ozone is one of the most powerful oxidizing agent, which is also a major photochemical oxidant. So here our correct option will be option second. Next question is, with reference to smog, which of the following statements are correct? Here statement A is Los Angeles smog is oxidizing, and statement B is London smog is reducing. So, as we know that the Los Angeles smog is also known as photochemical smog, which is oxidizing in nature, whereas the London smog is sulfurous smog, which is reducing in nature. So here both are statements correct. So our correct option will be option second. In next question, we have to choose the correct statement. Statement A is volatile organic compounds, oxides of nitrogen and sunlight are essential for photochemical smog. Statement B is photochemical smog is predominantly formed during the summer season. Statement C is the nitrogen dioxide dissociates by sunlight at 300 to 400 nanometer. Statement D is molecular oxygen dissociate by sunlight and provide atomic oxygen for ozone formation in troposphere. Statement E is tropospheric ozone concentration is maximum at noon on a given day. So here, as we know that it is nitrogen dioxide whose photolysis gives the atomic oxygen. So here, by eliminating option D, we will get our correct answer, which will be option second. Next question is, pan is formed by the oxidation of which of the followings? So here, as we know that the peroxyacetyl nitrate is formed by the oxidation of volatile organic compounds and hydrocarbons. So here our correct option will be option D. Next question is, the general molecular formula of pan-type compound is? And here the correct option will be option second, that is CXHY, OO2 and NO2. Next question is, photolysis of nitrogen dioxide occurs at radiations of wavelengths. And here the correct option will be option D, that is at less than 390 nanometer. Last question is match type of a question in which we have to match air quality index with its category. So, as we know that least the air quality index, more good quality of the air will be. So, from 0 to 50, the air quality will be good, and from 400 to 500, it will be severe. From 51 to 100, it will be satisfactory, and from 201 to 300, it will be poor. So here our correct option will become option second. That's all for today. Hope you liked it. We will come back with another video. Till then, thanks for watching.